So hello, welcome to the massive series of linear integrated circuit, and we are going to discuss about open loop configuration of operational amplifier. This is the open loop configuration. Open loop का meaning है that there is no connection between input and output. This is open loop configuration. There is no connection between this terminal output and these two terminals input. So we will proceed with this. So we can write here in open loop configuration, in open loop configuration, this is the point of discussion. In open loop configuration, there is no connection, between input and the output. So this is the condition, and we can write and opamp works as high gain amplifier. Since this is open loop configuration, so its gain will be very high. In previous class हमने देखा था in ideal voltage transfer curve, जैसे ही डिफरेंस बढ़ाते थे तो बहुत हाई आउटपुट मिलता था और एक पर्टिकुलर टाइम के बाद, एक सर्टेन वोल्टेज के बाद वो गेन सैचुरेट हो जाता था. सो दिस इज हाई गेन एम्पलीफायर. This is the high gain amplifier. This term is very important. Open loop gain is very high. So there are three main configurations we can write here. There are three open loop configurations. Open loop configuration. It depends कि हमारा जो ऑपरेशनल एम्पलीफायर है when at which particular terminal we are connecting the input. हम किस टर्मिनल पर इनपुट को लगा रहे हैं, हम किस टर्मिनल पर इनपुट वोल्टेज को लगा रहे हैं, वो डिपेंड करेगा कि किस तरह का कॉन्फ़िगरेशन है. सो वी कैन कैटेगराइज इट लाइक one is non-inverting opamp. One is called as non-inverting opamp. दैट मीन्स कि इसमें इनपुट वोल्टेज हम केवल नॉन इन्वर्टिंग टर्मिनल पर लगाएंगे. एंड द सेकेंड कॉन्फ़िगरेशन इज इन्वर्टिंग ओपैम्प. नेक्स्ट इज इन्वर्टिंग ओपैम्प, इसमें केवल इन्वर्टिंग पर लगाएंगे. एंड थर्ड वन इज नोन एज डिफरेंशियल एम्पलीफायर. थर्ड इज डिफरेंशियल एम्पलीफायर, डिफरेंशियल ओपैम्प, जिसमें हम इनपुट दोनों टर्मिनल्स पर लगाएंगे, इन्वर्टिंग पर भी लगाएंगे और नॉन इन्वर्टिंग पर भी लगाएंगे. सो फर्स्ट वी विल डिस्कस अबाउट नॉन इन्वर्टिंग operational amplifier. And we know that for operational amplifier the gain is denoted as A. What is this? This is the gain of op-amp. Gain is always output voltage divided by input voltage, and in operational amplifier input voltage is basically the difference of voltage, that is V1 minus V2. This VID is V1 minus V2. So we will proceed with, first we will discuss about non-inverting operational amplifier. First we will make its circuit diagram, then we will discuss it. So in non-inverting op-amp, the input will be connected to only at inverting terminal. So we can make here op-amp like this. This is the symbol of op-amp. We can connect here like this. This is symbol of op-amp. At this terminal we are getting the output. This is inverting terminal, this is non-inverting terminal, this is at pin number 6, this is at pin number 2, this is at pin number 3, this one is V1, this is V2. It will amplify that difference, that is VID is equal to V1 minus V2, V1 minus V2. This will amplify the difference of these two. And we have two more terminals, one is 7, another one is 4. This is positive supply voltage, DC supply plus VCC. We can write here plus VCC. This is minus VCC. So what we need to do, we have to connect voltage at this non-inverting terminal. This is the non-inverting terminal. This is the non-inverting terminal. So we will connect voltage here. So we have to use a resistance. We always prefer to connect a resistance whenever we connect any kind of voltage source. And this is the voltage, that is sinusoidal voltage plus minus AC voltage, and this voltage supply is V input. So we have connected this input at non-inverting terminal, and what we will do at inverting terminal, we need to ground it. That means V2 becomes 0. इसको हमने ग्राउंड कर दिया तो V2 हमारा 0 हो गया. एंड बी रिमेंबर देयर इज नो कनेक्शन. ध्यान रखिए, यहाँ पर आउटपुट का इनपुट के साथ कोई कनेक्शन नहीं है. ना तो यहाँ पर कोई वायर कनेक्टेड है और ना ही इन्वर्टिंग टर्मिनल के साथ कोई वायर कनेक्टेड है. सो दिस बिकम द नॉन इन्वर्टिंग ऑपरेशनल एम्पलीफायर. वी कैन राइट हियर दैट इनपुट is only connected at non-inverting terminal of op-amp. Input is only connected at non-inverting terminal of op-amp. And what about inverting terminal? Inverting terminal is grounded. Inverting terminal is grounded. So V2 becomes 0. So we can apply that formula of gain in which we can calculate the gain. So this is A is equal to V output divided by VID. So it will become V output divided by V1 minus V2. Since this V2 is 0 because non-inverting terminal is grounded, V2 becomes 0. So V output divided by V1. This become V1. So what we can write here? We can write here that output is simply A into V1. And what is this V1? Since there is no current because this input resistance is infinite, so there is no current flowing in this terminal. Similarly here in this terminal no current is flowing. So what will happen? This V1 will become V input. In this resistance no current is flowing, so this V1 become V input. So we can write here as A into V input. This is very important. To understand that output is equal to A into V input. So we can conclude it like the output is A times greater than the input. Output is A times greater than input. That means output is greater than input, means this is an amplifier. Output is greater than input. That means ki this is working as an amplifier. This is working as an amplifier. And one more thing that we can say here, that output and input both are in phase, because here the sign is plus. So we can write like, if 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 we are applying input like this, सपोज करो जो हमारा इनपुट है वो कुछ इस तरह का है, दिस इज 0, दिस इज द इनपुट, लेट्स से दिस इज योर V maximum. So what will happen? The output of this input signal will be like, the output of this input signal will be like this one. This is T, this is V output, and this become A times Vm. So these both input and output are in same phase. There is no phase shift. What is this? This is the phase shift. Phase shift. So if we will apply input at non-inverting terminal, then there will be no phase difference, no phase shift between input and output. So we need to remember this verdict also. Now we will discuss about inverting operational amplifier, in which we will connect input at inverting terminal. We will connect input at inverting terminal. So this is the symbol of opamp, and we are getting output from here. This one is 6 number pin, and we have inverting terminal, non-inverting terminal. Similarly, we will prepare this circuit also as we have prepared for non-inverting. This is 7 number pin, that is plus VCC. This is 4 number pin, that is minus VCC. Here we have V1, this is V2, and this is the difference VID, that is V1 minus V2. Now what we will do, we will connect voltage at inverting terminal. So here we have connected a resistance. Let's say this is R input 2, and the voltage that is connected here is plus minus. This voltage is V input 2, and this is grounded, and this non-inverting terminal is also grounded. So we can write the input voltage is connected only at inverting terminal, and non-inverting terminal is grounded. Non-inverting terminal is grounded. So we can analyze it like, we can write here that V2 will become V input 2, because there is no current flowing here. So this resistance will not have any kind of drop, any kind of voltage drop, and this V1 will become 0. So we will utilize these two values. So here the gain A will become V output divided by VID. So this can be written as V output divided by V1 minus V2. So this become 0. So this V output is basically minus of A times V2. That means minus of A times V input 2. That is the voltage connected at inverting terminal. So this is the equation that we have found. V output is minus of V2, A times V2. This minus is very significant. इसका मतलब हमें समझना पड़ेगा. So simply we can write output is A times greater than input. Output is A times greater than input, but in opposite phase. This is very important. But in opposite phase means there is a phase shift of 180 degree. There is phase shift of 180 degree between input and output. This minus sign represent if we are connecting any voltage at inverting terminal, then there will be a phase shift of 180 degree between input and output. We can understand it like if we have this input, like this. Suppose this is the input that we have applied. The maximum value is Vn. This is the input. So what kind of output we will get? We will get this kind of output. We will get, this is 0. This one is T. This is V output. And this is opposite in phase. So output will be like this. And what will be the maximum value of it? We have seen that it is A times of input. So maximum value will be A times of V1. So there is a phase shift of 180 degree between input and output. That represent opposite phase. That represent opposite phase. So if we are connecting input at inverting terminal, then there will be a phase shift of 180 degree between input and output. So next is differential op-amp. In differential op-amp, the input will be connected in both of the terminals, input as well, inverting as well as non-inverting, and similarly we can do the analysis of that also. So first we will prepare its circuit. In which we will apply input at both of the terminal. We can see here like this is the symbol. We are getting output from here. We have two terminals, one is inverting, one is non-inverting. This is V2, this terminal is V1, and we have difference as VID, that is V1 minus V2. So it will amplify the difference of this, and two external DC supplies here, that is plus VCC and minus VCC. And now we will connect battery here. So battery is like, in inverting terminal we have resistance, that is R input to voltage plus minus, this is V input to. Similarly we will connect voltage here. This resistance is R input 1 and the voltage is plus minus, this voltage is V input 1 and this is ground. So this is the circuit. So we can write here input voltage is connected to both terminals, inverting as well as non-inverting, both terminals. And if we will do the analysis that what kind of output we are getting, so the gain will become V output divided by VID, that become V output divided by V1 minus V2. So here V2 will become V input 2 and V1 will become V input 1, because there is no current in these two terminals, since we are having infinite input resistance. Here we have infinite input resistance, so both of these terminals are open, both of these terminals are isolated. So we can write a generalized formula for output of a differential amplifier is V output is A times V1 minus V2, that we can write here V input 1 minus V input 2. V input 1 minus V input 2. This is the generalized formula for differential opamp. So output is great. So we can write output is A times or greater than, output is A times greater than the difference of, greater than the difference of input voltage, difference of input voltages. Similarly, we can say here, we can write here that if V input 1 is greater than V input 2, if V input 1 is greater than V input 2, then there is a phase shift of 0 degree between input and output. And if V input 2 is greater than V input 1, then there is a phase shift of 180 degree between input and output. So this is the conclusion of differential operational amplifier. This is very important configuration to understand. There is no feedback between input and output, so there are chances to become the output to be saturated. So we need to overcome this problem, and to overcome this problem we have to discuss the closed loop configuration. So in next lecture we will discuss about closed loop configuration of operational amplifier. So in next lecture we will discuss about closed loop configuration. So thank you for watching this video.